That's wonderful news. So glad the stream has started, everyone. Let's all be lovely and enjoy the RS/6000 power supply reverse engineering. It's a grand day for it.
Bringing love and lighting up the night. Feel the rhythm, everything's alright. Dancing close, hearts are intertwined. Oh, jammers in the house, we'll keep it tight.
Welcome back, Ben. So lovely to see you back in chat. Hope you're having a grand day.
In the house, I love it nice. Dance together through this endless night.
Ugh, the adverts are on, folks. Let's give it a wee pause while Majenko enjoys a break.
Chloe McCoon, she's in the zone, tapping away. She's got her own throne, buzzing keyboards, wires to go. Welcome to Majenko's, let's start the show. Click, 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 she's ready to strike.
Or lovely to see you back, Chloe Raccoon. So glad you're here, Hen.
Raccoon power, shining bright. Second tunes, all through the night. Sound.
Edge, thanks for sticking through those ads, folks. I know they can be a wee bit tiresome. You're all lovely for bearing with them.
Pizza in bed sounds bloody good right now, actually. You like the new bot voice, do you, Nav? Oh, hello Ben, hello Chloe, hello Nav. We decided to turn the bots Scottish. Just for fun. Because why not?
A warm welcome back to Navixo. So lovely to see you back in chat, dear. Hope you've been having a grand day.
Right, well we're back at this silly power supply again. Alrighty then, yes. Back to this power supply, reverse engineering. And we're on to some slightly more complicated bits of it now. Some bits hidden away under here and this bit over here. So wish me luck. But first things first, I actually want to remove the B plus and B minus wires because it's going to get a bit more complicated and I want a bit more flexibility with it. RS6000 PSU versus Majenko, round 3, ding! Any excuse to have a quick moo, that's what I say. Any excuse for a moo. I need to log into Mastodon more often. If I can do this with the Moo Machine, it's kind of too big. Okay, I'll melt it. Where's my folder? My flux would help.
Welcome back, Matt Inks. Lovely to see you back in the chat, dearie. Hope you're having a grand day.
You just recycled an RS6000, how dare you! You could have sent us the power supply first. Damn you, we're trying to get 3 of them going and none of them are working.
Good to
Hey
see
Matt,
you
by the way.
Hammy's
Hey Hammies.
It's lovely to hear you here. Enjoy the RS/6000 power supply reverse engineering.
Which model of RS6000 did you recycle? Yeah. Come on, melt. No idea it was used. Oh, right. Not a 43p then. That's what we're working with here. Okay, I have mooed. I'm happy now. I've had my daily moo. We can get rid of that whole section now and focus purely on here. That's better. I can actually get in there now more and see what there is. Right. You think you still have the drives? They had weird connectors. Weird connectors? Drives? Sure they weren't just scuzzy? Where are we? Over here, aren't we? Stack of HBI titanium boxes. Yeah, but they're no good over there, are they? They should be over here. Scuzzy. Scuzzy 3 to be precise. Oh, ESDI could be. We had an MCA based RS6000 originally, and that was scuzzy. That's scuzzy 3 with a bit of rat shit in there. The SDI uses the same as MFM. That's really old then, isn't it? Because our old RS6000, which was MCA, was most definitely scuzzy. The same as what Chloe just said, yes. Right, so this is what we're reverse engineering. I want to do this section over here today. Initially, there's not a lot here, but what is here is buried underneath. So back to here then. So first things first. Let's look at these bits here, which are next to that jumper, which are capacitors. Where's my tweezers gone? Where's my straight tweezers gone? There. Okay, so we've got a green capacitor and a ceramic disc capacitor going across that. I doubt I can easily see what that capacitor is. Can I? Oh, I might be able to. Is it that one? Yeah. That one there is... Hey, Vital Knieve. You plucked the wrong acronym from your mental cupboard of ancient crap. MCA PS2s with single BH connector. That's as zoomed in as I can get.
A warm welcome back to Vitakin. It's lovely to see you back in the chat, Gary. Enjoy the RS/6000 power supply reverse engineering.
I can't quite make out what that's saying on there because I've got this on a tiny little screen here. Let's zoom it in a bit. That looks like upside down 0.0032. I'm not sure. 1. Not sure. You fixed your lights, have you, Chloe? Well done. Let's turn it around. It might make more sense the right way up. .0082. Is that 8.2 nanofarads, do we think? And a J. That's 0.0082 something. I'm assuming 0.0082 microfarads, is it? So 8.2 nanofarads. Possibly. Whee! So that goes from pin 4 of IC2 to ground. IC2 pin 4 is RC. Going to ground, it may as well go to that. That is definitely an eyeball there, yes. Right, next to it is another capacitor, which is a disc capacitor, and is an X7R. Where's the capacitance on that? It's a 102. That's a 1 0 and 2 zeros is 1 nanofarad. I do believe 1000 picofarads, and so is the one next to it there, Jatha. Whatever that is. So we are. Hey, G-Pen. That's coming from pin 3, isn't it? There. pin 3 to ground, and also pin 3 to pin 4.
Jump in the ride, let's hit the road. Jeep is here with the tail to a run. Cats in the back, vibing on the
Very delayed. I don't know why it was so delayed.
welcome to the chaos to the vibe.
A warm welcome back to the stream, Jeepin 247. It's lovely to have you here, and I hope you's enjoying the RS/6000 shenanigans.
Right, so let's just get the ref des for these correct.
Who's nicked me fucking batteries?
C30, C27. It's a Cobmeister. C30, C27. Then we have another one of these.
Ach, it seems like chat's having a grand old time reminiscing about ancient storage tech. Ben's mental cupboard of ancient crap must be overflowing. And Chloe, tempting Ben with pizza again, are ye? A mischievous wee thing.
Let's just move these down. Then we got this one goes from there across to there.
So lovely to have you back.
And
Hope you're having a good
is C26. Nice little network of capacitors we've got going on here. So that one goes there, I believe, and this one goes here. That links to there. That links to there. That links
Princess
to
Fuzzy.
there.
That's a bit of a personal question, hen. Let's just say I'm always trying to spread a wee bit of joy in chat. And Marika
And that goes to there.
is sounding lovely.
Excellent. That's that little bit done. Better because Cob's here. Absolutely, everything's better with a Cob. How do you have a mischievous wee? And I like the way you're calling the bot thing. Okay, next we have a diode, I think, going across the top of there. A Zener diode, ZD2. Going across here, which is to ground, and to whatever signal this is here, R20. R20, we have a resistor on the power that then goes to ground. Zener diode there. That's probably giving us something like a 3 volt or something like that. As opposed to the, no, a 5 volt maybe, that instead of the 12 volt that the switcher is getting. So that's here, isn't it? Yeah. This here has a Zener diode. There's one somewhere else that I've used, isn't there? There. There. This is ZD, what was it? ZD2. G-pin. Stand on the far side of the Jensen and hope the cleaners don't catch you. That's not mischievous. That's malicious. Almost, but not quite. So this has to go here. It's only malicious if you intend to miss. Fair enough. I've not got that one down there labelled properly, have I? That one should be ZD3, not D1. Right. What's next? This component here, what is that? There's a resistor covered in spooge up there. Is that it? That's it, isn't it? R40 covered in white gunk.
Right then,
Why did they
folks,
use all this white
just a
gunk?
wee heads up, adverts are on now. Enjoy the break, and we'll be back shortly.
It's a 1K anyway. I can see enough there. It's brown, black, red. 1K. Ooh, PIMS. Sounds like a good idea to me. So this is pin 3 here. Has a 1K resistor to something, but we don't yet know what. Pin 3, that's the output of that, isn't it? That's CS, I'm sorry. That was R40, was it? R40, yes.
Thanks for sticking through those ads, everyone. It's a wee bit of a necessary evil, isn't it? You're all lovely for bearing with it.
Right, there's more resistors, I believe, here, buried under the blob of white goop. 2 resistors and a diode again. Another bloody diode. Let's see if I can get this goop out of the way so I can see what the resistors are. One of them is a... looks like... is that 20 or 200 ohms? Could be either at the moment. I don't know what the other resistor is yet. Let's dig some holes into this goop and add more IPA. Yeah, come on, soften and peel away, please. Hey, RF.
Heute Abend ist was los, RF-Programme. Du bist der Gast in unserer Gaudi Lederhosen. Stolz und grandios. Willkommen hier zum Magic Coast. Rave Party auf geht's. Lass die Sorgen
Welcome back,
verschwinden.
RF Program. I hope you're ready for some lovely tunes and a wee bit of tech.
Come on, Goop. I'm half tempted actually to undo the screw on this heatsink and remove the whole heatsink. Just so I can get in there. It's only two hefty solder lugs. Yeah. Another excuse to moo, of course. Do I want the Robotron gong? No, I think I'll... Thanks for the offer, but I think I'll give that one a miss. Oh, that's not going to turn with that. Let's try that one. There we go. Gotcha. And of course it has a nut on the other side of it, doesn't it? Because why wouldn't it? Oh, couldn't have just threaded the heatsink, could they? No. Come on, prise this away. Doesn't want to separate. It's been on there so long, it's welded itself. I don't want to. There we go. I don't want to break this MOSFET because that would be expensive. Great asparagus, oh dear. Well, if there's a Robotron computer going around the place, I'm always up for strange Z80 clones like that, yeah. Anything weird like that, absolutely. But a doorbell, nah, that would just get too annoying, because I would have to have it as a redeem. And, well, with the likes of Cobb around, it would get a touch noisy. I do like this moo machine. Oops. This has got a bit of a ground plane with it as well, which doesn't help. Let's add a bit of paste. There we go, that's starting to go now. A bit around here. A bit around here. Okay, that's loose. Now we've just got to deal with the goop that's attaching it. Any price limit? £10? There we go. You can actually see what's in there now. And get at that lump of goop.
Princess Fuzzy, but Moor. Moor, there you go, a wee bit of Desseldring, just for ye.
A bit of what? Soldering. €200, that's a bit steep for my wallet at the moment, I'm afraid. I've got car insurance coming up. You need insurance if you crash or park your car in a stupid place where someone nicks it. Or the Morrison's car park where people try and drive into you. Because there's only about 3 inches between cars. We're getting there. You can almost see what this resistor is. This one I can see is a 20 ohm. That's a small signal diode, I believe. Or it might be a Zener diode, hard to tell. Kansas is a stupid place also, yes. Or if you drive through any ANPR cameras, yeah. Not driving, or driving without insurance is a bloody stupid idea these days. I think this might be another one of those weird resistors. Which is why they covered it in goop. Or maybe they just covered it in goop because they just had some extra goop left over and needed to put it somewhere. Progress is gradually being made. These strange resistors, this is one looks the same. I believe this is just an ordinary resistor, but the goop is taking the surface off it, so you can no longer see what it is. This, I think, is a 3K resistor, or it used to be. Before the goop got at it. Yes, 3K. $2.979, yeah. You were once nearly arrested in a US National Park because the rangers didn't believe you walked there by foot. Okay. Americans don't walk. Now, I need to get the ref des for this diode, but it's underneath here. Is it a D or is it a ZD? Where's it gone? There it is. I think that's just a D, but what number is it? Is that a 17? Do we have a 17 there? I think we do. Yep, I'll call that a D17. Just. Okay, so we have a 3K, a diode, and we have a 10 ohm. Any more bits on 17? I have 17. Do I hear 18 anywhere? Any 18, 18 anywhere? 18, 18. Any of us on 18? I'm looking for 19. Anybody 19? 19, 19, 19, 19, no, 20. 20, I'm looking for... So we have on here 3K, diode, 20 ohm. So a 3K, what's that going to? That's going to pin 6 on there, isn't it? Which is the output. Okay. So this resistor goes first straight through a 3K. And that is R12. I was cutting out a lot during the auction here a bit. Oh dear, that's a shame. My audio's doing weird stuff. Is it okay at the moment, or is it cutting in and out? Or is it just because I was getting excited? You blame the batteries, whether they're in the mic or me. Well, who knows? It's fine now. It's probably just because I was getting excited. These things happen. I could always just not talk. Then I can't cut out. Okay, so we've got that goes there. Now we have a diode and the other one, the other resistor in parallel here. So let's grab this Zener. No, it's not a Zener, is it?
Right then,
It's an
folks,
ordinary diode.
time for the adverts. Let's give Majenko a wee break.
Which way round is it? It's the other way round. And a resistor across it. Of resistor number 49. Value 20 ohms. And this diode is D17. Make a note that I clip when excited, yes.
Right then, thanks so much for enduring those ads, everyone. It's lovely to have you all here, and I appreciate you sticking around.
So those go like that. To that, okay. Now this is the main FET here. So I'm guessing that's the gate. What is it? Besides a huge chonking thing. A 2SK962. 2SK962. I'll bet it's not in here. There's a 2SK3019, but that's tiny. So just look for a generic MOSFET. Is there such a thing as a generic MOSFET? Here we go. NMOS.
Ugh, it seems we're having a grand time auctioning off pins and handbags. Just be careful, Ben. Chloe's handbag might bite.
Am I cutting out when I lean forward, am I? I shouldn't be. My position shouldn't make any Oh, hello. No, that's... Oh, I'm looking at the wrong scope there. My position shouldn't make the slightest bit of difference to anything. Unless the microphone is dying, which is not good news if it is. No, everything seems fine. I think it must just be your ears that are cutting out. I'm perfectly fine. Nothing wrong with me. Nothing wrong at all with me. Right. So what footprint is this? Title my sex tape. My position doesn't make the slightest bit of difference to anything. Yes. Okay, let's find a footprint. It's going to be TO of some form, isn't it? A TO3P, perhaps. Yes, TO3P.
Welcome, Swarm, to the stream where pixels flicker and the chattel peak. Though you fluttered off, your presence remains. In whispers of wings, echoes again. Here in Majenko's space we unite, to laugh and cheer through daylight.
A warm welcome back to the stream, a swarm of fed insects. It's lovely to have you here.
Hello, Swarm. Right. So I need the proper name for this. This is... Oh, it's Q1. Alright. That's actually named itself properly this time. Q1 is Q1. So... Now, how do I map this so that it works properly? We have a pin number of D. Right, let's see if I can find the data sheet for this one so we can get the right pin out. 2SK962. By Fuji Electric. Hello, this is Nighthawk. Are you receiving? Over. Okay. Ah, there it is. 1 is the gate, 2 is the drain, 3 is the source. Yep. So can I change the pin assignments without having to edit the entire symbol? No, I don't think I can. To SK, what was it? 962. Pin number 1. Okay. The source is pin 3. The drain is pin 2. SK962. There's Art Rocks. You don't need my flashing knobs. The flashing knobs! Eat this, eat this!
A warm welcome back to the stream, Hot Rocks Girl. It's lovely to have you here.
A gigantic mechanical penguin comes waddling across the snow-covered landscape, belching smoke and steam. It emits a loud gronk by way of announcing its arrival. It stops with a wheeze and its tail lifts, revealing a passenger and cargo bay. Out steps an Allison, wearing clothing better suited for a tropical paradise, accompanied by a number of sunglasses-wearing yaks and goats with beach umbrellas. The penguin's tail drops, and it recommences its sooty peregrinations. Aloha, peeps!
Hello, Alison. I think you're in the wrong place. I think you took a wrong turning. Yeah, in the UK there is no real benefit to electric vehicles if you do a lot of mileage. Because our electricity costs are just messed up. Okay. 2SK Crunch. Thanks. Thank you, keycard. That's one crash we've had. Hello? PCB editor. Gonna stay this time? Thank you. Schematic editor. There we go, let's just do that. F8, update, close, there it is.
Venomized Shark. So lovely to have you join the Majenko crew.
Thank you for the follow, Venomized Shark. Welcome to the stream fun. We are reverse engineering the power supply to an RS6000 because it doesn't work and I need to know why. And until I work out how it works, I can't say why it doesn't work. Okay, so the That goes to there, doesn't it? That goes into... in between these, isn't it? I think. Right, that's right. Right, so that big knob there is the heatsink, along with that one over there. This here is a big sodding resistor, I think. Yes, it is a big honking resistor. And that there is a largish capacitor. You and a hell of a lot else, other people in the country, Chloe, our housing really is not designed for cars. Even modern housing in a lot of places is not designed for cars. This is a honking great resistor. Somewhere. There it is. I think that's a brown at the top. Brown, blue, silver. Can never remember what silver means in a value. It's a dividing, but I can't remember how much it divides by. Honk for his sister. Or honk, honk. No, I can't do honks. My honks aren't good enough for me to join citation needed. So brown, blue, silver. 15. 1, 5 and no zeros. Silver for nothing. Silver is divided by 10, is it? And gold, what's gold then? Because you can get gold in there as well. Why did I load that one? I don't want that one, I want that one. Silver for nothing and gold for free. Silver's divide by 100, is it? So we've got brown, blue, multiplier is silver. Tolerance is gold. Calculate. 0.16 ohm. Brown, blue, silver. 0.16. There's a pink. Not on this one, there isn't. There's only gold and silver on this calculator. So this is a 0.16 and it's going to be a good couple of watts, I would have thought. So that goes from the source to ground. Ah, of course, that's what, yes. That's what CS is, isn't it? I know what CS is. current sense. So this is current sense resistor. So 0R16. You're going by Wikipedia because Wikipedia is always right. This is R13. Oh, an unlucky resistor. And the footprint. What we need is great honking resistor. Not found. Okay. It's a axial and it's an upright with a...
Och, hello everyone. Just a wee heads up, adverts are starting now. Let's be patient and enjoy the break. Aye.
Maybe that one? Let's try it. Nah, it'll do. Go back. Wait, stop that. Yeah, it's a bit weedy. Bit of a weedy one, that. Can we get a bigger one? Ah. Haha.
Oh, bless you all for enduring those ads. It's lovely to have you here, and I appreciate your patience.
There we go. That's more like it. That's a bit more like that. What have we got on the board here? A chonker. The current sense resistor for the current limiting system. Be interesting to see what current is going across that actually when it's switching. Not something I can easily measure at the moment though, unfortunately. Big chonkers for the win. Because if there's too much current, it could be going into overcurrent shutdown mode. I don't know. The ideas on how you can create a flickering LED light, simple and easy, found ways, but all over the top. What sort of candle kind of flickering are you thinking, Owen? Or is it?
A warm welcome back to Owen Morton, 525.
In what sort of way?
Lovely to see you back in chat, dearie.
I can see noise on the microphone. Is it screwed at the moment? Right, give me a sec. I'll bet it's my stupid USB audio interface. Is that sounding better now? It's bloody awful, this M audio crap. I need something better. Am I fixed now? That's better. Good. It's that stupid M audio thing again. Right. Replicate a campfire type thing for your model train. Because you need noise. If you want flicker, then you need noise. and filtering and threshold, and it's tricky. I would probably do it with a very small microcontroller and just program it. A very small program, an 80 Tiny or a PIC-10 or something like that. I once made a candle, an electronic candle using RGB LED and a PIC-10. It worked quite well, and the PIC-10 was in a SOT23 package, so it was really, really tiny. Only 6 pins, just enough to do an RGB LED flickering. So that's the way I'd do it, is just with a very, very small microcontroller with almost no power. An Arduino Nano, yeah, that'll work fine, yes. Well, that's pretty much what the M Audio does, Ben. It's fine when it works, and it'll just randomly not work. So, yeah. It's got, whatever I have, it's got to be USB, because my computer is just absolutely chock full of cards. No room for anything else in there. So, what I'd like actually is a Focusrite, what are they now? Ruby or something, isn't it? The new version of, or the newer version of the mixer that I've got at the moment, which is Firewire. The newer versions are USB. That would be nice. But they're just far too expensive. I only got this one for free because it's Firewire and it doesn't work with anything. RME is pretty much as stable as you'll get, but they are cheap. That's the problem. The good stuff is not cheap. Donate your old ESI to Ben, yes. Still working. Yeah, good. I mean, I did for a while have my Focusrite connected to the PC through a Firewire card, but Firewire on Linux is just utter trash. And it was just crap. Because just nothing works with it now. It's just bit rotted to hell, and nothing works anymore, so... It's got to be USB or nothing, unfortunately. And the M Audio is the best of the USB that I've got at the moment, really, I think. Because it needs to be bi-directional, which my little whatever it's called, iOD, no, not iOD, Ion, is only unidirectional. That's only input, but I need output as well, because I need to be able to hear. So, you run out of pizza, Chloe? No, not good. Right, where were we? Capacitor. That's the next thing here. You only ordered a 10-inch. Well, that was short-sighted of you. Right, so this capacitor is... Ooh, I need to put in a couple of traces on here, don't I? That goes to there. That goes to there. So we've got capacitor here. And something else next to it, haven't we? No, we haven't. That's B plus and B minus there. That's the inputs. So this is a capacitor across B plus and B minus. Is it just an ordinary capacitor? Or is it a MOV or something like that? It's labelled as C3, so it's just an ordinary capacitor. It'll be a few hundred volts though, because there's good 300 odd volts coming in there. So that's just straight across B plus to B minus, which is here. C3, I don't know what size it is, so I'm going to put it as a 1 nanofarad. And we need a chonker. Let's try 12.5. Oh, good guess. Look at that. Okay, so this comes along here, down here, into these. Excellent. Right. Oh. Thank you, KeyCAD. Harami is a win the lottery purchase class, yeah. Mistake. My mistake was saying the word excellent. Yeah, sorry, it should have been excrement, shouldn't it? Right. But because I am now in the habit of constantly saving, it's exactly how it was. Because I just pressed save when it crashed. Okay, so now we have coiliness. 1, 2, 3, 4, 5, 6, 7. I think that's 7. Then that isn't 1, is it? 1, 2, 3, 4, 5, 6, 7. 2 in, 7 out. Whew. This could be fun to try and find. I doubt such a thing exists. And I'm not going to be able to buzz it out in situ. Because there are pins joined together on here. Where are we?
Ew, It seems like everyone's got strong opinions about audio interfaces today. Ben, I hope your streaming radio stations are still playing, despite the drama.
Got 2 input pins at the top there for the primary coil. Then we've got, I guess those 3 are together. I guess those 3 are together. Or are they? I don't know. Unless those are together. That's ground there, definitely. That's a whole lot of ground. Well, you can't see, can you? Let's zoom it out a bit more. This here is a whole lot of ground. All of this lot here. Gotta be ground. Especially since it goes to all these ground pins down here. So that I know is ground. So those 2 are both connected straight to ground. It looks like there's a bit of a dry connection on that one there, actually. Maybe I should moo it and remove it and then actually measure them. See what's connected to what. That might be a good idea. Any excuse to moo. Remove. Important onion decisions. To onion or not to onion? That is the question. Thanks for the follow. Jet Pinky. Welcome to the channel. Thank you for the follow. Mugun's very happy with these pads. It's gone straight through.
A warm Scottish welcome to Jet Pinky. So lovely to have you join the channel. I hope you enjoy the stream.
Moo Machine. We love the Moo Machine. There's a little bit of solder on these ones still. Now, oh yes, of course, why wouldn't it be? Come on, there we go. Out she come. And it's stuck in, of course. Right, so now we can buzz this out and see what is connected to where. 20% more solist, yeah. I swear this board is 80% Scholastic. There we go. Continuity. Right, so we know these two are connected. Actually, let's go to resistance, shall we?
Okay. Just a wee heads up. Focus alerts are on now. Let's be patient, and then we can get back to the lovely RS/6000 reverse engineering.
Oh, excuse me. Right. So we've got this pin connects to no, no, yes, no, no, no. Okay. I should make a note of this, really, shouldn't I? Time for GIMP.
Etch, thanks for sticking through those ads, everyone. I know they can be a wee bit tiresome. You're all lovely for bearing with them.
Okay, so we have the core. We have the primary. Hey, time for some proper artwork. Now we have one coil coming in, which goes around and then back out. Now the next two pins along, do they communicate with each other? No. Okay, so 2 and 5 and 6. 2, 5 and 6. Okay. Pin 3. Forging signatures. That was yesterday, yes. Goes to 7. So that's the arrangement we have, by the looks of things. So we have 2 single coils and 1 split coil, for some reason. Scramble wound, yes. Strange pinouts on these things. So this is the bottom view. Which is like that. Better than Womble wound, yes. So now I am going to be looking for or creating a transformer like that. There is no such transformer already. So what I'm thinking is I'll take this one and edit it. I'll just drop this in over here. And edit with symbol editor. Wait, stop that. Okay, so I want to take this, but not all this lot. All these little curly bits. I don't need the middle pin for these. But let's put that there and that there. Okay, and we're going to add a couple of... Wait, come back. Couple of lines in between just to tie them all together. Right. Need to discuss poor Orinoco's flow. Poor Orinoco. The problem with all these transformers is they're all custom made for the specific application. Going to sail away on Orinoco's flow. That must be some flow. Quite enough of that, me thinking. There's 3 big, long, complicated numbers on this, and none of them mean anything whatsoever outside of delta. I might call this the MP130B. MP130B. Save that in my custom library and save it. Edit with symbol editor. Right, so that's saved. Write it down in the book of days. We don't want that URL. Go away. Can I delete it? Come on, delete it. Delete. Ah, stuff it. I'll just empty it. Right, the footprint, I don't know what we're going to have. Right, so I'm going to need a footprint which is based around 1, 2, 3, 4, 5, 6, 7, 14 pins. So if that's going to be pin 1, this one will be pin 4. So now, how does this relate to our little doodle here? So we have one of these coils between 1 and 4, which is actually 14. 1, 2, 3, 14, 13, 12, 11. 14 and 11. That's 14 to 11. So that's one for let's renumber these. So this is one, so 4, 5, 6, 7. So this will be 8 here. Shrink that a bit more. So 8, 9, 10, 11, 12, 13, 14. So 12 to 8 is the other one of these. And the strange one is 9, 10, 13. So 9. 10 and 13. Right. Save, so it's time for KiCad to crash. Quite. Hence why I saved it. Better than seeing a sheep farmer's bun, a shepherd's moon. Oh dear. You're all as bad as each other. Right, can I find a suitable... if I could spell, could I find a suitable footprint? The answer will be no, most definitely not. But I thought that about the last one, and I did. But if I can find one that's close, I can modify it. That's 14 pins. It is incorrect, but it might be the right size. No, it is not. Not by... Well, it's not too far off on part of it. But it's too wide. Let's try that one. It's the wrong number of pins. But is it the right pitch? Not quite. Let's find a different one. What are you doing, you stupid muppet of a program? Right. This is almost there. A little bit wide actually now. Let's try that one. Nope, it's too wide. Right, our pitch is not bad for that side, but the rest needs to go up. And the numbering is wrong as well, but I can fix that. Right, let's take this as a basis. And open in Footprint Editor. If I then move these up like that and update footprint, it didn't. Let's save this actually as MP130B. And did I give it create a no, where are we? New library, whatever. Project Transformers. There we go. MP130B. Save. So I go into here and I look for MP130B. Update. Close. Right. That'll do. It's not quite right, but it's close enough. Footprint Editor. Chloe declares Maltesers to be a dessert, especially if you sprinkle them on ice cream. So we don't want that, we don't want that, we don't want that, we don't want that, we don't want that. That is right, isn't it? Yes. Pad number 1. Pad number 4. 8. 9. 10. 11. 12. 13 and 14. Fix these gaps. Save, close, update footprint. And rotate it and move it. And I think that's right. Connect that to that. And yep, that's connected to there. Huzzah! So nice to go to the kitchen, hit the lights and not have a dark patch in the corner. That is good news. It's not a perfect footprint, but it does enough for the reverse engineering. So the other one goes straight to B+,
Okay.
which is
Just a wee
over
heads up,
here.
since the adverts are on now. Let's be patient while they finish up, then we can get back to the R/6000 shenanigans.
So this wanders off this way, through these pads here. A bit of extra solder there to thicken up that thin bit. And the same there, isn't there? And that goes to there. Nearly done on the primary side. A perfect footprint is when you get to kick a manager up the arse, yep. Right, all we have now is just a little bit here, which I think is all about
Thanks for sticking
protection,
through this,
basically.
everyone. It's a wee bit of a necessary
magnetic
evil.
EMF protection, back EMF and things like that. We have more chonker. A big fat chonking resistor there. We have a coil. We have some 3-pin package there, but that's on the secondary side, isn't it? That's on the secondary. All the primary side is what we're interested in. So we've got a resistor, 2 capacitors, 3 diodes. And is that a link there? Yeah, there's a link there as well. And then that's it for the primary side. So let's start off with capacitor and a diode of some form. Is it a diode? Yes, it is. It's a strange diode. The capacitor is a 221. That's 220 picofarad.
From Athens glow to the retro screens.
Hey, PC.
What vintage means. Old machines with stories to tell. Now the stream's alive and it runs so well. So shout out power with the crew who boot their dice. Standard to from floppy this tool.
I don't like these diodes.
A warm welcome back to PC Matters. It's lovely to have you back in the chat, dearie.
Additive circuits, chips divine, retro bytes with their Greek design. Raise your glass, enjoy the theme. PC Mothers powers up the stream.
D9 there. I don't like this type of diode. I've had bad experiences with these diodes before. I don't know if there's anything special about it. What? I mean, yeah, they're not fun diodes, these ones. That's going to be a very high voltage TVS diode or something, isn't it? It's almost directly across the coil. Even looks like a cherry bomb, yes.
Ach, it seems we're having a grand time discussing insulation and onions. It's a bonny wee chaos, isn't it?
And avalanche diode. That's the one, yeah. Not DBS, avalanche. Yes. Directly across the coil. Well, almost across the coil. It got in series with this resistor by the looks of things. So this is coming from the... It's basically going across from here through a resistor to here. That's B plus there, isn't it? So that's going to be the... Yeah, it's going to want to go this orientation. To here, I believe, with a capacitor across. Let's grab that one there. Like that. That's the arrangement we have there, I believe. 1 kilovolts upwards, yes. Spicy diodes. This is D9, wasn't it? Yeah. Let's just see what that gives us in the way of footprints. No, that's not the right. It needs to be much bigger. No! Stuff you. Go over there, you. Not quite, but we're close. Can I get it any wider than that? That is pitch 5.08. I need pitch higher than that, but I want it vertical. There's no vertical ones with a higher pitch. Okay, let's go for a horizontal one with a 762. You'll do. No. Yeah, that's right. That capacitor goes across there. Needs numbering. What number is that? That's C11. And it was 220 picofarad. Close enough for bot work, yes. Okay. Then there is the big resistor. This resistor. Footprint. It's not an axial, it's a radial. go bigger than that. That's smaller. I thought I asked for a bigger pitch. Or is that, no, it's length and width with pitch. Ah, P5. P7, let's try that. There we go. Except that's not where it goes. Because it goes that way around, just there, and there is a capacitor there over it. Like so. This is a massive one. 1 kilovolt rated. 472. 4700, 4.7 nanofarads. So 4700 PF. And it is C unknown because it is under goop. Of course. Why so much goop? This was heatsink holding down goop. We've got 2 more diodes to add actually after this. Stupid goop. Get out of the way, goop. It's a C. I've found the C. There's a 1. Is that a 0? It's C10. Okay, C10. And this has got a reasonably large pitch. Fancy, get some rock. Absolutely. Try a 10mm pitch. Oh no, 8mm pitch or 764mm pitch. Or 7.5 I should say. That'll do. Rotate it around, put it where it should be. Connect these all up. Not the dreaded goo. Yes, the dreaded goo. Still fighting the goo. We hate the goo. Right, 2 Zener diodes up here. Going from here up to here, apparently. And they are both facing downwards. Like that, I do believe. You need to play a copy of World of Goo 2 sometime. You back their crowdfund and all, fair enough. So we've got ZD7 as the lower one, ZD6 is the upper one. Right, these are all, well, one of them is lying down, ZD7 is lying down, and is a little longer than that. But this one here is standing upright. But bigger than that. Well, not much bigger, but a little bit bigger than that. There we go. Looking good. Looking good. When it's standing upright, something you think Ben would have issues with. If you did make up that 1.7 litres of PIMS, you certainly would have, yes. Right, so we now have, albeit somewhat messy, the entirety of the primary side circuit done, I do believe. Let me just have a sanity check, make sure there's nothing we've missed out. I don't see any missing paths. Everything looks good. You might need someone to help you to bed, but you reckon you could just about stay on your feet. Especially if you've got something to lean against. Right. You know what? It's on to the secondary side now. Well, hey. A lot of it is to do with this mystery module on the side here. I have no idea what this module is. Why, thank you, Swarm. This is the DC443, apparently. And it is double-sided. 2 large chips. Lots of discrete components. That could be another little regulator or maybe a FET there, possibly. I have no idea what it is. The DC443. Let's have a quick Google, see if we can find the DC443. It's a digital camera bag. No, it's not. I doubt very much we're going to find anything.
Let's give Majenko a wee break.
Takes longer to find the desired redeem in the list than some of them take to play, indeed. It needs a bookmarking system, doesn't it? So you can bookmark your favourite redeems. Suggest it on the user feedback. Bookmark redeems.
Oh God, I maybe shouldn't have done that.
Something else for Twitch to screw up. Yep. No, we're not going to find anything about this module. Clicked idiot in my favourites and got a fart.
Enjoying these ads, everyone. It's lovely to have you all here, listening to Lazarus Start by Everett Almond. It's a wee bit of rock to brighten your day.
So, no, we're not going to find anything at all about this module. What's the main chip on it? Or this chip, anyway. Let's get the old scope going. DC443 has been replaced by a single chip, more than likely. Where are we? Microscope. This chip here is... $33991H727. Wouldn't surprise me if it was simply... That's a ST. It wouldn't surprise me if it was something like a LM339. This is a 14 pin, isn't it? Quad differential comparator. Possibly. This is a 14 pin jobby, is it? Yes, it's a 14 pin. The outs are at the top, power and ground are the next pair down, and then all the ins are below that. Oops. So, looking at this, does that make sense? Yes, it does. I think that's just an LM339 quad comparator. Don't know what the one on the other side is, can't get to it. Set up as a dual window comparator. Quite possibly, yes. It's probably to do with power good and things like that, and it'll be the EPOW, won't it? It'll be for the EPOW. To know whether the power is about to disappear. On this side, it's a bit dark in there. Doubt I'm going to see anything, am I? It's another 339, yeah. I thought so. Same ship. So it's probably 2 lots of the same thing, or 4 lots of the same thing. Comparing the voltages or something. Yeah, that'll be EPOW control, I suspect. Which is supposed to indicate to the computer that the mains has disappeared and all you've got left is what's in my capacitors. 4 rails to measure, 4 window comparators makes sense, yeah. Yeah, so that'll be EPOW, that. So I think we can ignore EPOW for now. We shouldn't need it. Because it's basically saying the only power you've got left is what I've got in my capacitors. So flush your buffers and get ready to switch off. So you can fit 8 instead, yeah. Right, so let's, I suppose, start by looking at the... So we'll just quickly do the output filtering of the standby circuit and the bootstrap power circuit. We have no idea what the problem is yet, RF, no. But what I might do actually is put these components back in place so that I don't lose them. That would be sensible, that. I know we don't do sensible on here, but it would be a good idea, I think, to put this back in. And then the heatsink as well. The problem is someone took out the transformer, yeah. Although, saying that, no, I won't, because we've got all these bits down here that I want to get at. So I won't put those in yet. They can wait, because we still want to get at these bits. The problem is that Ben had this in his possession first, and he's cursed. Yeah. Sensibly been upgraded and more sensible with forward planning. Yeah. Unusual, that. Right, so this is the standby and bootstrap power here, which is this little bit of circuit down here. And comes off this transformer here. Okay, so what is the first thing we have? Eerily sensible. The first thing we have is a diode. Actually, I should number this transformer properly. This is T2. And this over here is T1. Right, so this pin here goes first of all to a diode. Which direction? Is it that direction? It's probably that direction. Yes, it is. This is KiCad Road Rally Race. Yes, it is, and welcome to the chat. Welcome to the stream. This is KiCad, and it's terrible and keeps crashing. Okay. This pin here is that one down there, which goes through all sorts of things. Which is this one here also has a diode, is the middle one of there. What version? I have no idea. I run Arch, so it's the absolute latest version you could possibly imagine. 906 we're on. You're still on 8. Ah. I use Arch, by the way, yes. That's why it keeps crashing, Ben. Oops, I put that on the wrong pin, haven't I, there? Should be on that pin. That's better. The 906 release notes are just filled with fixed crash. Guess what? You failed. Well, but in fixing the crash, they created a whole load more crashes. This is a bit big, actually, this diode. That's a bit better. It's not. No, it's a bit. Even that's a bit small, actually. So we want that size, but wider. That one there, perhaps. That's a bit better. If you update to 9, can everything transfer over or start from scratch with parts and footprints? I think from 6 upwards there have been no real changes to the formats of the files. I think it's 6 and upwards, I think. So 8 to 9 should be perfectly fine, I would have thought. It was only when it went from 5 to 6 that things changed.
Ugh, it seems Belgium's KiCad Adventures are providing more entertainment than the RS/6000 itself. Seems like a good time to use !TRR and share some richer fun. Bye.
Okay, so what have we got here? This looks to me like it's going to be ground, isn't it? What have we got? Oh, that's a capacitor there, isn't it? That's a large electrolytic, 16 volt 470, going between from this pin to ground. So from there to its internal ground. Or possibly ground. Actually, which way round is this capacitor? Yeah. That's going from there. There's a capacitor.
Welcome back, Majenko. So lovely to have you back, dear. I hope you're having a grand time.
Oh, TRR comes out as my name, does it? I thought it should come out as the bot, but maybe not. Oh well. And what was this? This was a 16 volt 470 microfarad. And it is a radial it's going to be an 8mm diameter with a, I think, a 5mm. That certainly connects to pin 9, amongst other pins. That's that one there. Comes down, and that's going to be the virtual ground for this, or the ground for this side, isn't it? Put this in down here as well. Complete this silly little loop. Oh, why did you just delete that? I want... Oh, keycard. I want that connection in. Why are you deleting it? Just put it in place there. Thank you. Stupid keycard. Pretty sure that's ground. The way it's wandering all over the place and things like that, I think that is most likely going to be ground. But it may not, you never know. And what's this here? Oh god, it's another one of those, isn't it? Why? Why do we have one of those over here? Why? What possible function could that have? That's between... those two pins there, isn't it? That's this one here. It's another avalanche. Yeah, another avalanche diode. Going between 1 and 7. Or 6 and 7, I should say. Between there and there is an avalanche diode. Must have been, Ben, must have been. Hey, Trade Splatter. Very hazardous skiing conditions, yes. Where's my avalanche over here? There it is. And it's going. Cathode goes towards
It's
the
lovely
edge
to
of the
have you here,
board.
dearie. I hope you're enjoying the RS/6000 shenanigans.
The edge of the board is. That edge. Yep, that's the right way up.
Ach, the adverts are on, everyone. Let's be lovely and patient while they play.
The snow has disappeared from the weather forecast. Yeah. You don't get snow down this direction. You've got to be north of Cobb. Or even north of Chloe to get snow at the moment, I think. Avalanche diodes are fast, whereas the original 4000 series were tuned for less than 75 hertz. Fair enough. Fair enough. You rarely get snow, yeah. We may get a 5,000th of an inch of snow in March, maybe. So this time last year, you had surprise snow on the morning you were heading over to your colleagues to look for Fax Station 2000 cabling. God, has it been a year already? It's been a year of Vax Station 2000 already. And still no sign of the 3800. How's that going anyway, Ben? It hasn't, yes, I know. Have you spoken to your colleague yet? Right, between these two diodes here is another capacitor with the negative stripe upwards. This is between pins 9 and 10. That top one there and that one there. That is definitely going to be. Yeah, that's definitely going to be virtual ground, isn't it? Let's move that across over there. I say virtual ground, actual ground on this side. Isolated ground. Sort of both too annoyed at something else to get down to interesting business like the Microvax. Fair enough. Time's running out. Time's running out. We're halfway through the month. Over halfway through the month, aren't we? Yeah. Half the month is gone. This is a much smaller one. It's just that it's my birthday this month, so I wanted it as a birthday present. 25 volt, 47 micro. Wider pitch. Wider pitch needed. I mean, a concert on Saturday buys you some extra time. It does indeed. I want a 5mm diameter, but with a wider pitch. I want D5 P5? I can only get D8 P5. So the whole thing is far too gigantic. Pitch is right, but the size of the capacitor is way out. It's also backwards. Hang on, is that right? I'm confused. Because that doesn't go there. That goes there. That's why. I hate these transformers. They're such convoluted pinouts. And it needs to go the other side of the diode, of course, doesn't it, here? That looks better. You thought about simple heating in your room today, but in the end you didn't play any Far Cry 6. You decided to come talk to the bot instead so you can play real Cry. Yes. Came from one to the other, you're bringing your 338 Lapua Magnum rifle. To put even bigger holes in the bot. Don't blame you. Don't blame you in the slightest. Right, I don't understand how this is working. This is weird. Right, so where's this diode here going? It's going to whatever this component here is, going across that. Which is... just a link. Okay, so that's just a link to there. Then it comes down here to whatever this lot is. So that can wait. Because first I have this one right here. And that one is...
A warm welcome back to RHK77. So lovely to see you back in chat, dearie.
$78L15. We have a 7815 in here. Hey MJ, you made it. Not too well today, so just lurking. Still wanted your jingle though, fair enough. Thank you for joining us.
With 100 bits, RHK77 says,
Cheer 100.
Oh, thank you very much for the bits, RHK. Yo92.
Welcome back to MJ, so lovely to see you again, dear. Enjoy the RS/6000 reverse engineering.
He's in the chat, wandering for night.
So this pin here is where? That pin there goes to one of these pins on this one, but I'm not sure which one. VI probably. Yes, but that's the wrong footprint. So I need the wider version. Just tried the JLPCB PCBA plugin in KiCad. You're very impressed. How easy it is to create a PCBA order with it? Yeah. I've never tried PCBA through JLPCB. I know somebody that has, and they found it very good. But we did it all manually. No fancy plugins, because we weren't using KiCad. And it all went very swimmingly. They're very good with it. Tend to have all year round suck. It rarely actually extreme, but oscillates between cold, wet and miserable, and hot enough that we regret building all our homes to cope with the cold, wet and miserable. Yes. Planning on doing something similar. You don't have the kit for SMT nor the room for it at the moment, so thinking of getting JLC to do those. You do the odd through hole for connectors. Yeah, fair enough. And if it's just a one-off, you can get me to do it for you. I hand build SMT. That cost though. Cost more than JLC probably. But we can do it on stream. When your house was built, you didn't do hot. No, your house was built during the time of the frost fairs, wasn't it? They tended to have much colder winters then. Okay, so this here is going to what I am calling ground. Pin 2 is ground. That's going to what I am calling ground, I think. Pin 9, come on. 9 is that one there, yes. So this is what I'm calling my ground. I'll call this just ordinary ground. Why grind pin 2? Ground, not grind. So this goes wandering around here through that blob of thickening solder. We'll stop off at there and join to there. Pin 2 has been bad or good. Depends what kind of grinding. So we should have a nice clean 15 volts coming out of there. That's something to check actually. Do we get 15 volts out of that? I can't tell because it's all dismantled. That is certainly one thing to check on. Do we get our 15 volts? They're doing it tomorrow instead of today. Oh, well done, Ben. Busted your balls getting the multimeter rigged up to monitor it last night. Fair enough. V5 farm, I smell the blood of an IBM man. The digital copy will be used so that I can work out how it is supposed to work, so that I can predict what voltages and waveforms I can expect to see on certain devices and confirm whether I do or not. Because this power supply doesn't work and you can't get them. They can't be replaced. So I need to work out why it's not working and fix it, basically. There will be one tiny, tiny little component that's not quite right. So, yeah. Once I know what's wrong, I can fix it. Once I can fix it, I might have a chance of getting the RX6000 working. I've currently got an ATX power supply rigged up on it and it's not working. And I don't know if that's because the motherboard is basically buggered or whether the power supply is not suitable. So it briefly supplies power, then shuts down, yes. Why that is, we do not know yet. Technically correct, the best kind of correct, yes, absolutely. Okay, this one here is a 7805, isn't it? I do believe. 7805 CV. So let's add a 7805. And a TO220. Did it not do it? Come on. Ah, didn't give me a footprint, did it? TO23 vertical. There we go. And this goes just here. Lightning bent a shell because he's using TPIB. So that connection to the cathode of that, which is there, goes to pin 1 of this here. This is getting messy. Cross up, Ben. Can't edit IPv6 firewall rules in the web interface. Oh dear. I'm assuming this connects with the other ground here, doesn't it? Yeah. That goes to that. Just the heatsink across there. I'm going to ignore that. Or am I? No, I can't really ignore that. Because that's acting as a link for the ground. So that's going to have a link going across it, isn't it? The reason I'm reverse engineering it is so that I can work out how it works, so that I stand a chance of repairing it, because it doesn't
For some
work.
adverts. Let's give Majenko a wee break.
So I need to know how it's meant to work, to then compare that to how it is working, so that I can then work out why it isn't working. Because it no worky. I've got a broad idea of what there is where and how it's supposed kind of working, but there's a tricky bit to do with the feedback that I don't understand quite how it works, and that the feedback connection is being used for two different purposes. So how those two different purposes are being enmeshed together, I don't know. Do I have a trace what's not working? Well, it turns on and then it immediately turns itself off again. And I don't know whether that's because it's not getting the signal to say stay on, or whether there's a fault with the some part of it that's saying it's
for enduring those ads, everyone.
turn it off because there's a fault or what. I don't know. And until I understand how the whole feedback circuit works, I can't tell whether it's actually functioning. Not sure I can get to that. No, I can't. Because I'm not configured for IPv6 here. I do have IPv6, I just don't have it on my local network here. I'm from George, I should be able to. Yeah, George, I can ping it. But I have no IPv6 from my computer to my router at the moment. I'm just not configured for it, so I just haven't bothered with it. No, I wouldn't bother, Ben. No point, really. Right, so we've got our two voltages, 5 volts and 15 volts, supposedly. Where am I going next? Am I going out sideways, or am I going to carry on down? We're getting down to that mystery module now, aren't we? So that's basically our power supply voltages there and there. There must be capacitors across this somewhere, I would hope. There's a little capacitor there to the right of that one.
Och, it seems Belgium its IP6 adventures are causing quite a stir. Someone needs to
Which
give him a wee hug
is-
and a cup of tea, aye.
Give him a wee hug. I don't think you want a wee hug. That's a capacitor going across there, isn't there? From the output to ground on this one here, there's a small capacitor. one of these ones here, I think. Okay, that's the output capacitor of that one done. Looking good so far, that. Back to room 454 with you, yes. You take wee hugs off a pre-approved list of huggers. benhuggers.txt. No, it's more likely type sys$system : benhuggers.dat. MS don't like a lot of things, Chloe. Working for a start. What's this component going across here? Is that a capacitor? Or a resistor? Or an inductor? Eh? Is that... No, that's going there. There's an inductor, is it? Inductor there, resistor going up there. That's a big inductor there. Well, not that big. A leggy inductor. Okay, let's find a suitable footprint for an inductor. It is a radial inductor with a diameter of, I would say, 7-ish. Let's try 7.8. Now, this gets tricky. Because that needs to go to there. How can I do an angular... I don't want to... 018118055. That's your number, isn't it? How can I do a different angled rotation? Oh, there we go. Thank you for that. Playing Mastermind rules. 5 white pegs, no black. So if 5 of those numbers are correct, just not in the right place. Not just a pretty face. Yes. Thank you very much. Yes, it's... KiCad is strange to get used to. I haven't been using it... Well, I have been using it a long time, but I haven't used it for a long time. And I'm still reminding myself how all these things work. They work poorly indeed, yes. Right, where does this head off to now? It comes down to here. What is this? We've got capacitor here. Maybe I should put that capacitor in first, working our way down. Which is a 50 volt 1 microfarad. That's going from... Where are we? That's... this pin here, which is going from that jumper, which goes to that pin there, which is the output of the diode from pin 8. Go away, you. That's that one there, okay. So, wending our way across to let's move this to here, put that there. That's 1 microfarad and 50 volts. Then I assume that goes to ground, does it? Oh. Thank you, KiCad. Splendid of you. Absolutely splendid of you. No, I don't want the symbol editor. Cancel that. Go away. I want the schematic editor. Okay, I was just about to add this capacitor here, wasn't I? Which goes from there to there, was 1 microfarad at 50 volts. Let's put it in first. And it goes here. Yes, that goes to ground. So this one comes up here to here with a link to there. Oops. And then across to there. Then this comes up here to here. This is the heat sink. I'll have that just as a link for the time being. To go there. Excellent. Put it in first, who's on second. Ha ha. Okay, so what is next? The output of this inductor here goes down to that, doesn't it? Which is... by the looks of things... no, I'm looking at that. What's that? That's capacitor across there. Okay. Capacitor to ground. And it is a... 25 volt, 47 micro. Capacitor to ground, ground control to major. Yes, very good. Very good. So that snuggles into there. These capacitors are too big, but it doesn't have any with the right size footprint for a smaller capacitor. Now, what comes out of the bottom of here? Actually, tell you what, let's go... how many pins? 1, 2, 3, 4, 5, 6, 10, 11, 12, 13, 14, 15. There are 16 pins there. There we go. Generic connector, single row. Okay. Footprint. We'll call it a pin header. 1 by 16, 254. One by 16, P254. Oh, and of course it's not quite 254, is it? 254 is the widest pitch there, isn't there?
Right then, folks. Just a wee heads up, adverts are on now. Enjoy the break and be lovely.
Shame you can't scale the footprint. Just stretch it a little bit on the y-axis.
Thanks for sticking through those ads, everyone. It's a wee bit of a necessary evil, but you're all lovely for bearing with them.
I'm on the wrong setting here, aren't I? Right. So I'm going to move each one down a tiny amount from its neighbour. If it will. Of course, it might be the board image scaling that is slightly off. Resulting in a footprint that isn't quite aligned. Nearly that. Right, file, save as, new library, project, mystery module. There we go, a custom footprint just for that. And that is close. Could do with doing the same again, really, I think. But that's close enough for now. That'll do for now. Poor old Majenko, diligently working away whilst chat sods off in all directions. Yep, don't you always. We've reached the end of my stream time anyway, really. It's 10 o'clock. We've made some good progress though. We've finished the entirety of the primary side. And we've got most of the standby power supply in place. I love the War of the Worlds as well. The Jeff Wayne. I was listening to it the other day. It's a classic. Absolute classic. Now's his Thunder Child. Don't blame you. That sounds like a follow. Road Rally Race, thank you for the follow. Is it red? Red weed? Red weed all over everything. Right, I am done for the night. Your Naz's Thunder Bucket.
Road Rally Race. Welcome to
I thought that was Cobb was Thunder Bucket.
So glad to hear you here.
That's Thunder Pants, isn't it? Sorry. Oh, grey. Ironclad, yes. Right, job done for tonight. Brain melting again. My brain's always melting. I need to get a new brain, one that doesn't melt all the time. If we all say please, maybe Ben will continue the stream at his channel. No, he won't, I'm afraid. No. We can look around for someone to raid though, if you fancy. See if there's anybody interesting raiding, raidable. Anything going on in science and technology anywhere? Your Naz is black box. My Naz is Cutie Pie. Because it's a smallish, quite cute looking Dell. It's My Little Cutie Pie and it's spelled QTPI. You're welcome, G-Pin. Wrong window, there we go, right. This looks interesting. Bonnie and Boota. Looks like they're doing something technical. Should we go and raid a random, completely random channel? Dell is not cute. This one's reasonably cute, actually, for a Dell. What's Computer Booter?
It's new electronics category. You can.
Good old adverts. What's going on in there? Is this raidable? Come on, adverts. Oh, I'm hungry now. KFC. I could murder a KFC right now. Looks like they're rebuilding a computer. A laptop by the looks of thing, or something, is it? Or a console, is it? I'm not sure. Could be a PlayStation, actually. Should we go raid them? It's PS5. I thought it did, yeah. Hey, Daft Punkle. Let's go and raid Computer Booter, shall we? Right. Well, thank you very much for joining me this evening. We've made some good progress there. Let's go and raid Computer Booter. I'll be back on Thursday. I'll be back Thursday. You won't see me Friday because I will be rehearsing for the concert that I have on Saturday. So I will be back after that on the Sunday. So Ben, you've got 2 days this weekend you can do. Friday and Saturday. Both ends of... You can do both ends of Shelby on Friday if you like. But I'll be back on Tuesday anyway. They are dafty, yes. Well, I say they, it's me. I'm on the committee. I'm one of the people that decides these things. So, right, let's go to a raid of Computer Booter and go and say hello to them. So, thank you very much for being here today, and I will see you on Thursday.